Platform Down Under for the month of May. Once again, Martin Catherall and myself will be hosting this month's session, and I will be handing over to Kevin very shortly, where he will be taking us through locking down Azure Synapse. This session is being recorded and will be made available on the Data Platform Down Under YouTube channel, where you can come back and watch not just this session, but any of the sessions that we have had recorded over the last 16, 17 months that we've been running this meetup group. If you do have any questions, feel free to put them in the chat or raise your hand, and we can ask those questions to Kevin throughout this session. As it is being recorded, if you can just make sure that you do stay on mute during the recording, that way we don't have any interference for anybody else who's wanting to watch this session. So with that, I'll look at handing over to Kevin to take us through locking down Azure Synapse Analytics.
All right, thank you, Warwick. Let's take control and start presenting. So chat, you're going to be right here, right in front of me this whole time. I see you. So if you have any questions, please do feel free, put in messages. I will respond as is prudent. In the meantime, welcome everybody. As mentioned, my name is Kevin Feasel. I am a Microsoft Data Platform MVP out of Durham, North Carolina. And I also run a predictive analytics team there. In addition, I have a website called Curated SQL, where I try to find and link to 5 to 10 interesting posts per day on topics all across the data platform space. So it's curatedsql.com. What I'd like to do is provide a high-level overview of security in Azure Synapse Analytics. And I stress the term high level because there's a lot involved in Azure Synapse Analytics. It is, by my reckoning, the mashing together of about 5 separate products. And there's quite a bit that we're going to want to cover here tonight or today for you. So we will cover network security, workspace security. We'll talk about connecting to outside resources, securing the 3 major pools that are out of public preview, and I'll give you some notes on additional tooling. So let's begin with a quick discussion of what is Azure Synapse Analytics, just in case you're not familiar with the notion. This is Microsoft's platform for modern data warehousing. And there are, as of today, 4 data sources that are that compose it. The first is dedicated SQL pools, the second, serverless SQL pool, the third is Spark pools, and the fourth is Data Explorer pools. Let's talk about each one very briefly. A dedicated SQL pool used to be called Azure SQL Data Warehouse. The idea here is that this is a massive parallel processing implementation of the Kimball method for warehousing. The idea is that it works extremely well if you have proper Kimball style facts and dimensions, and at least 1 terabyte of data. Your largest fact table is about 1 billion records or more. Then dedicated SQL pool will work really well for you. At much smaller data sizes than that, we can talk about it. But given the price, given the expectations and performance, those are sort of the you must be this tall to ride the ride types of requirements. So that's mostly for warehousing. Spark pools are intended for data transformation, machine learning, and also some sorts of infrastructure work. These run Apache Spark clusters on demand, and basically you can use it as part of data transformation, data processing, or machine learning. Those are really good use cases for Spark pools. The serverless SQL pool is a standalone method of accessing data that is stored in Azure Data Lake storage using a T-SQL interface, meaning I'm querying records that are not stored in a SQL server. They're not stored in a dedicated SQL pool. They're actually files in a data lake, but I can write SQL to access that data, treat it as though it were in a proper database. Comes at a pretty nice price, about $5 per terabyte process. That's $5 US per terabyte processed. And I have a whole nother talk on the Serverless Sql Pool if you're really excited about that. Data Explorer pools allow you to do real-time analysis on large volumes of data. This was originally intended for working with log data, so log analytics, and uses the Custo query language to access this data. I have a separate talk that is all about Data Explorer pools. In this case, because they are still public preview, I don't want to talk about securing them. And the reason is that given they're still in preview, there is a chance that security related matters may change between now and then. The advice may not be completely solid at this point, and therefore I wouldn't trust information today. I would wait until they're generally available. At that point, then we can talk about security. So from a security perspective, if I were a security officer in an organization and people were talking about Data Explorer pools, I would probably tap the brakes on that pretty hard. It's public preview, not ready for prime time. So a little bit of brief pool advice. You may have one serverless SQL pool. You must have one serverless SQL pool. You may not have two. You get one created for you when you create a Synapse workspace. That's it. You cannot delete it. You cannot create another one. You cannot rename it. You can't really do anything to modify it. You can create relationships inside of the serverless SQL pool, but you can't destroy it on accident. I would recommend creating one Spark pool per relevant task. Spark pools are cattle, not pets. Build them up, destroy them. Take them as far as they need to go, and then get rid of it. You can always build another Spark pool. By contrast, a dedicated SQL pool is more like a pet than cattle, in the sense that you're going to have the one dedicated SQL pool per warehouse, and you'll maintain that thing. You'll want to get it right. It's not trivial to tear down a dedicated SQL pool and build up a brand new one. You can do it, but it's not the easiest thing in the world. If you want to save some money and you don't need the dedicated SQL pool day in and day out, I would pause it when it's not in use, because this can be a very expensive product. The fifth product that is slapped into this Synapse world is pipelines. So these pipelines are based on the code in Azure Data Factory. It makes it easy to perform ETL, extract, transform, load, as well as ELT, extract, load, transform types of operations. Synapse Link, arguably a sixth product that's thrown together in this bundle, is a way of connecting to other data sources. The first connection is Cosmos DB. So there's Azure Synapse Link for Cosmos DB to allow you to read Cosmos data into your dedicated SQL pools or into your Spark pools. Subsequently, there have been announcements around using Microsoft Dataverse as well as SQL Server 2022 to connect to Azure Synapse Analytics. In the future, there will probably be other links as well, but those are the three that I know are public. So we have all of those things to think about as we begin talking about security. But before we begin, we're not just going to go create that Synapse workspace and start throwing stuff together and hope to secure it later, because there are a few things we've got to talk about before we can move ahead. First, got to talk regulations, regulatory compliance. So organizations are going to be tied to a variety of regulatory regimes. If you're familiar with your own organization's regulatory regimes, you can check out Microsoft compliance offerings. And let me just drop a link in chat to that. This will help you see this in more detail. It'll show you, for example, oh, well, if you're in this industry and you're affected by this regulatory regime, here's the types of things that you can do. Here are the products that are covered under that umbrella. And here are maybe requirements for what you would need to accomplish in order to meet the requirements. So the way I phrase that is important because regulatory responsibilities are shared responsibilities. And by this, I mean Microsoft does some things to make their products available for consumption under a regulatory umbrella, but we as consumers of those products also have our share of the task. So for example, Microsoft controls the hardware, but we're going to control who gets access to that hardware or who gets access to the software running on that hardware. Microsoft can encrypt the data, but we control some elements of encryption. As an example of this, Microsoft will encrypt your data. The question is if you're going to use their keys or if you're going to use your own keys. And in some cases, you don't have a choice. Basically, they're going to encrypt using their keys no matter what, but your choice is to encrypt with your keys on top of what they've used. So in some cases, we'll have doubly encrypted data, which is fine. Microsoft will control the networking, but you're responsible for that data. Just because it lives on their servers doesn't mean they're administering it in that way. You may use their tools to help prevent data loss, data loss protection using products like the Microsoft Defender Suite. But at the end of the day, this is really our responsibility as owners of the data. And as owners of the data, there are certain principles that I highly recommend people follow. First one, encrypt data at rest, encrypt data in transit. So data at rest, that's been kind of the standard for a good 15 years. About that time ago, I was working for a state agency in the US working with healthcare data. So HIPAA was just starting to get teeth in the US, and they started fining organizations for not encrypting data at rest. Since then, we've seen advancements where CPU costs have gone down enough that encrypting data, all data in transit, is a no-brainer at this point. Then we think about ensuring that the sensitive data is necessary to store. Do we actually need this information? Because if you need it, okay, that's fine. If there's appropriate business value in maintaining this information, so be it. We're going to protect it. But the best way to protect information is not to have it at all. So if we don't have it to begin with, or if we remove it when it becomes obsolete, that is going to help our security posture immensely, because even in the event of a breach, we limit the risk of exposure here. Finally, we're granting access as people need it, not necessarily as it is most convenient. And the extreme example of that is, for example, we don't grant everybody in the organization sysadmin access on a SQL Server instance just because it's most convenient. That's a bad idea. So yeah, we want to limit access to who needs it when they need it. Transitioning a little bit over to another concept, business continuity. This may not sound like a security issue up front, but availability is actually one of the 3 pillars of security. So I think it is relevant to talk about it here, high availability and disaster recovery. When it comes to high availability, Microsoft's going to be mostly in control here. If you're working with a dedicated SQL pool, those are distributed. They're highly available by default. If certain servers fail, things get moved over to other servers behind the scenes. We don't really have to think about it very much. The Serverless Sql Pool is also highly available. If nodes that are available behind the scenes fail, new nodes come in and take their place. That said, the service itself can fail. You can receive error messages that the service has gone down. So it's not like it's perfect uptime. Spark pools are where you can control things, because if you're following my advice of treating Spark pools as cattle and your Spark pool suddenly dies, whatever, set up a new one, start over, keep going there. So that makes it pretty straightforward there. You just spin up a new pool, forget about the old one, destroy it. Happened last month, still waiting for Microsoft root cause analysis. Yeah, that does happen on occasion, unfortunately. Fill in on occasion with whatever period of time you believe, because well, it does fail more frequently than I wish it would. So let's talk disaster recovery. On this side, it's more of a joint effort. Your dedicated SQL pool is going to take automated snapshots. The recovery point is 8 hours back. The retention is going to be 7 days. So they take snapshots roughly every 8 hours, and they'll keep those for 7 days. That said, you can take your own manual snapshots. This is particularly important if you followed that little recommendation I gave before. Like, for example, if nobody uses the warehouse after 5 p.m. local time, and you just shut it off at 6 p.m. local time and start it back up at 8 a.m. the next day. If that works for your organization, great. But that may be when the automated snapshots are taking place. So you might not actually have automated snapshots in that instance. And you may want to take manual snapshots every once in a while to ensure that you do have something. Taking a manual snapshot is really easy. It's just a quick PowerShell command. Dedicated SQL pools are also backed up to another region once every 24 hours. If an entire region goes down, your data is available in that other region. You may lose 1 day of data. The other pools, the Spark pools, the Serverless Sql Pool, they're going to store data in your data lake. And so if you're using Azure Data Lake Storage Gen 2, you can use geo-redundant storage. Geo-redundant storage means you're going to save copies in the current region, and you're also going to have at least one copy in another region available for disaster recovery purposes. So now let's talk about setup. Okay, we've gone through the regulatory requirements. We've thought about HADR. We've thought about what kinds of data we're going to put into Synapse. Before we go next, create. Couple of things on networking. There are two options around network security. Number one is the managed virtual network, or managed VNet. Number two is data exfiltration protection. So managed virtual network is real easy to set up. It is this radio button right here. And you turn that on, you get a managed VNet. So what does that give you? Well, what this does is actually on the next slide right here. But before I get to what it does, let's talk about something important. If you have created a Synapse workspace and did not turn on a managed virtual network, you cannot turn it on. If you turned it on when you created the workspace, you cannot turn it off. This is a setup only configuration setting. So you would have to create a new workspace. And also, there is no option to create a virtual network of your own. Either your resources are essentially going to be available public internet, or you're running on a managed virtual network managed by Microsoft. You're not going to be able to say, put this Synapse resource on my own virtual network that I have created and that I am controlling. The argument behind this is that the managed virtual network has everything configured so that the relevant ports are open and only those ports are open for the resources that are related to Azure Synapse Analytics. That it's a way of making a fairly difficult networking problem transparent to the end user. But that is something where if your networking people are very hands-on and want absolute control, they may not like that answer. But it's also the same for things like Azure Databricks, where you'll have managed virtual networks there as well. So what does a managed VNet do? Well, first, if you have separate Spark pools, they're going to be segregated into their own separate subnets. What this means is that if I have one Spark pool that I'm accessing and you have a Spark pool that you're accessing, Your Spark pool cannot access nodes from my Spark pool. They cannot communicate with each other. There's no routing between them. So what that means is if an attacker happens to have found a way to get into an existing Spark pool, they're not going to be able to pivot over to other Spark pools that might contain more interesting information. It also isolates the Synapse workspace into its own virtual network. So that workspace is on its own. It opens up just the ports that are needed for communication with dedicated SQL pools, with the serverless SQL pool, with the Spark pools, with the Data Explorer pools, and nothing else is open. This also enables a concept known as a managed private endpoint. To understand why this is relevant, there are some resources in Azure that we may want to connect to from our Synapse Analytics workspace. For example, I may want to retrieve data from Azure SQL Database, or from Cosmos DB, or from SQL Managed Instance, or from some blob storage. If I do not use a managed private endpoint, there is a possibility that my Synapse Analytics workspace can, in the process of connecting over to Azure SQL DB, go over the public internet. Well, if data transits over the public internet to and fro, potentially somebody could be listening to that information being exchanged. All of that data is encrypted in transit using TLS, but if you don't want that public internet exchange, using a managed private endpoint guarantees that we route strictly within the Azure ecosystem. We never leave Azure servers when communicating from that Azure SQL DB and Azure Synapse Analytics, that all communications stay in the Azure cloud. So we never go over to the public internet. So what this does by creating a managed virtual network is it's going to create for you managed private endpoints to the serverless SQL pool, as well as any dedicated SQL pools. Also, it'll enable the ability to create more managed private endpoints to those other resources. Finally, you can turn on another box that is dedicated for data exfiltration protection. So data exfiltration protection is an option that reads, allow outbound traffic only to approved targets. So this works. It works painfully well if you're a developer. And what I mean by this, well, there are certain things that you would expect to be able to do as a developer that when you've enabled data exfiltration protection become either impossible or much more difficult to do because you cannot really move data out of Azure Synapse Analytics, except in very specific circumstances. So just like managed virtual networks, this is something you turn on at create time, and you may not turn it off afterwards. And if you didn't create it with data exfiltration protection enabled, you can't turn it on later. Basically, what data exfiltration protection does is it says you are allowed to communicate over managed private endpoints. You may not communicate over the public internet. Your dedicated SQL pools, your serverless SQL pool, your Spark pools, not communicating over the public internet. Furthermore, you can limit specific Azure Active Directory tenants to which you can write data. So what's the benefit of this? The major benefit is, let's suppose somebody found a way to gain access to your Spark pool, and they want to pull data out from this Spark pool that you've got some really sensitive data that is available in here, and they want to exfiltrate that data to AWS S3, their own S3 bucket, or to their own servers, or to Pastebin, or any machine on the public internet. Can't do it. You can't access those outbound. You can't create outbound connections to public internet resources. Furthermore, let's say that they've got their own bad guy Azure subscription. Unless you have explicitly granted that capability to write to bad guy Azure subscription, they can't exfiltrate data to it either. So very powerful, but for developers, kind of limiting. We'll talk a little bit more about limitations when we get to the Spark pools, but you just keep that in mind. That this is my recommendation is managed VNets pretty much everywhere. Data exfiltration protection, I don't know about that. Maybe. With working from home becoming more predominant, how do we manage user remote access to the workspace, like opening up firewall holes for people with constantly changing IPs? Great question. Amazing question, because this is the slide that I'm at right now. So as far as access goes, there are some options available to you. One is that if you're using a managed virtual network, you can completely disable public network access. You could have people connect using a site-to-site VPN or a point-to-site VPN, or connecting in through Azure Bastion and into that Synapse workspace. That is going to involve some additional work. You can lock down the Synapse workspace. There is a way to basically peer a virtual network that you own with the managed virtual network and the Synapse workspace resource there. I'd have to dig up the link for it. I don't remember exactly where it is, but there is a way to do this. It is pretty complex. It is possible, though. That is probably going to be your best route. You can also enable IP address ranges. So you could have client IP addresses, but in your scenario where people are constantly changing IPs, my recommendation there would be use a VPN. Have that VPN. You're connecting to a known set of servers. You can open up those IPs and allow for communication pretty easily. The further scenario of really locking down such that you can only access through a bastion is possible. The easier answer is VPN. One other checkbox, little thing right here that is so easy and convenient to check. Allow Azure services and resources to access this workspace. It's such an easy checkbox and it solves so many problems. Don't check it. This is a trap. There are even cases in Microsoft documentation where they just have you check the box because it's the easy answer. It's usually not the right answer. Let me explain why. That checkbox, what it allows you to do is, if it's checked, Azure resources can access your Synapse workspace, regardless of whether you've got public network access or not. This is pretty good. It means what it means on the plus side is I don't need to set up any special rules to allow Azure Data Factory or a SQL database or Azure automation scripts or something like that, or an app service to communicate with my Synapse workspace. The problem is this is not just your Azure services. This is anybody's Azure services. Any machine that is running in the Azure cloud is going to be allowed, based on that rule, to access. Now, there are security roles. There are, IAM roles that we would have to set up. So it's not like it's just carte blanche connect to get all the data, but this is a potential gap. So where you might be thinking, no, the only people who can access this are, my own subscription, my own machines. That's not necessarily the case if you've checked that box. You can do everything that you would need to do with Synapse without checking the box, but it will be harder, and it may be significantly harder to do. So this is the very convenient answer, but it's usually the wrong answer. Okay, we talked a little about networking. Now let's talk about that workspace and what it means to secure the workspace itself. In access control, or IAM, you will want to grant most users storage blob data contributor against the Azure storage account. That is your data lake storage account. So enroll assignments, you want to make sure that pretty much everybody who's going to use Synapse has that storage blob data contributor role in your data lake storage account. So many things require it that at this point I don't even blink. It's like, okay, fine, you can contribute to storage blobs that will give them access to the data lake. So that is something to keep in mind. I wouldn't give it to everybody in the organization, but if you have access to this warehouse, you're essentially going to need access to be a storage blob data contributor, even if you're reading data. Now, within Azure Synapse Analytics, there are a series of role-based access control roles. These are what we call workspace level roles, and they're going to control what a user is allowed to do. In addition, there are going to be separate roles for the dedicated Sql pools as well as the serverless Sql pool. So let's talk about what these Synapse workspace level roles look like. The first one is the Synapse Administrator. This person gets control of everything in Synapse. In addition to Azure owners, these people are allowed to assign RBAC roles to others. So if you want to assign somebody a role, you must be either an owner of the workspace resource. And going back to this screen right here, if you went to access control or IAM for the Synapse workspace and added somebody as an owner, then they would be able to assign any workspace roles. A Synapse administrator can also do this, but you still need Azure permissions. Those permissions are either owner or contributor on the workspace. If you want to do compute resource management, compute resource management means create a Spark cluster, destroy a Spark cluster, create a dedicated Sql pool, delete a dedicated Sql pool. If you're building new machines or working with data explorer clusters, if you're building or destroying machines, virtual machines, you're going to need owner or contributor on the workspace, in addition to whatever workspace RBAC roles are necessary. So for a Spark administrator, for example, you can create and manage Spark pools if you are also an Azure owner or an Azure contributor. You can work with Spark notebooks, work with job definitions for Spark jobs, but you cannot run Synapse pipelines. You also cannot grant access to others. If you are a Spark admin, you cannot make anybody else a Spark admin, with the exception that you are also the owner of the Azure resource, that access control IAM owner. The analog to the Spark admin is the Sql Administrator. Here, you get full access to the serverless Sql pool and may also manage dedicated Sql pools. Management, you can create logins. You can grant access inside the Sql pool. You can do what we think of as management tasks or DBA tasks on a SQL Server instance. We can work with scripts. We can work with credentials. We can create linked services, but cannot run a Synapse pipeline, cannot grant access to others. There is a role called Artifact Publisher. Artifact Publisher is just a fancy way of saying somebody who's allowed to save a script. So this person is allowed to read and manage published code artifacts. They can read scripts that other people have saved. They can read jobs that other people have saved, or Synapse pipelines that other people have created. They can review the outputs of those resources. Artifact Publisher by itself doesn't actually give you the ability to run any of these things. You can see them, but you can't run them. Artifact User allows read-only access, but you cannot save. So usually you would give somebody Artifact Publisher in addition to a SQL admin or a Spark admin or one of these other roles that I'm going to talk about. Credential User is a very special role. This one lets you use secrets. Credentials, linked services require secrets. They require some ability to retrieve sensitive information, passwords, usernames, connection strings. So you're going to need that for things like pipeline runs. This is why I emphasized that the Spark admin and the SQL admin by themselves cannot run Synapse pipelines. They also need to be credential users. A compute operator is allowed to submit a Spark job or a notebook. A compute operator can also view logs, and they can cancel Spark jobs. The weird thing is, if you're a compute operator, you can cancel anybody's Spark jobs. So if you have a kind of a jerk who's a compute operator, they could kill your job. They can also run pipelines. They can view pipeline runs. They can view pipeline outputs if they're granted credential user. Monitoring operator is brand new. This is a role that was added about a week ago. A monitoring user is allowed to read published code artifacts, read outputs for notebooks and pipeline runs, view the Serverless Sql Pool, the Spark Pool, the Data Explorer Pool, and integration runtime details, but may not cancel or run pipelines, may not cancel or run Spark jobs. They may view, but they may not modify. A Synapse contributor is a compute operator who also gets full access to Spark pools and integration runtimes. So you can think of the monitoring user as sort of the read-only compute operator, and then the Synapse contributor is a compute operator who has a bit more power. They get full access to integration runtimes, full access to Spark pools. You can work with published code artifacts, but again, if you want to run the pipelines, you've got to have credential user. That's a really important role. Well, let's just say you want somebody who's allowed to write a SQL query. Well, that person, you should give them Synapse User. Synapse User can view details on SQL pools, Spark pools, integration runtimes. They're not allowed to view published code artifacts. You would also want to grant them Artifact User for that. Maybe Artifact Publisher. They may create new artifacts. Here's the really weird thing. If I'm a Synapse user, I can create a new SQL script that I may not be able to run, that I may not be able to save, but I can still create this thing in the workspace. It's a thing, and you can do that. I guess maybe I copy and paste it and send it to somebody else, but it's possible to get stuck in that hole. In practice, I'm not sure that's incredibly valuable. Generally, you're going to, the people who you want writing scripts, you usually are going to trust them enough to actually run the scripts or to save them someplace. But, whatever. I mentioned a little bit ago that pretty much all data is encrypted in transit, and all traffic to Workspace endpoints, I don't care if you're using a managed virtual network or not, is encrypted using TLS 1.2. You cannot disable this. You cannot change this. There's nothing you have to do to enable it. It's just there. So that is automatic. You cannot negotiate it down to 1.1 or 1.0. Negotiating down is actually a security flaw where a server tries to be very helpful and say, oh, you don't understand TLS 1.2. Well, let's go back to an earlier version. Well, those earlier versions may have vulnerabilities that could be exploited. So Synapse says, oh, you don't understand TLS 1.2. Too bad. Come back when you do. And I have no problem with that at all. Everything that is communicating with Synapse is going to be able to interact through TLS 1.2. Every browser that's on the market today, every browser that's been on the market for a couple of years is going to be able to use TLS 1.2. The tooling that you use, SQL Server Management Studio, Azure Data Studio, it's going to be able to communicate over TLS 1.2. No problems at all. So now let's talk linked services. Linked services are a way that we can make connections to external resources. So these resources can be on premises. They can be in Azure. They could be in AWS. They could be in GCP, wherever. I have a screenshot here where I'm showing you some Amazon stuff, some Azure stuff, and some possible on-premises things like Apache Impala. For Azure services, you can connect using something called the managed identity. The managed identity is created for the Synapse workspace and essentially says, I don't need to use a password. I just have a credential that is created behind the scenes and is managed by Microsoft. Different services will allow you to create managed identities. You can create them for Azure SQL Database. You can create them for blob storage. You can create them for Synapse Analytics. And you can use these in lieu of creating user accounts with usernames and passwords that you now have to manage. Instead of managing passwords, sharing passwords, doing any of this stuff, you basically create or you have the application managed identity, or you have the system managed identity, one of those two, and you can connect using it instead of a specially created one that you know the password and it's stored in an Excel spreadsheet someplace. You can connect to other resources, let's say an S3 bucket. Store those keys, store those connection strings in Azure Key Vault. So you don't have to store it in a text file someplace. You don't have to store it in the data lake itself. You want to store it in Azure Key Vault, grant the appropriate managed identity the rights to be able to read that. So the Synapse workspace managed identity, you can grant it rights to go grab these secrets in this Key Vault, and that'll allow you to connect to this S3 instance and retrieve data from S3 buckets. Managed private endpoints, like I mentioned before, require a managed virtual network. And this is going to be the best way that you can connect to other Azure resources. It'll be the most secure way in two senses. One is that managed private endpoints really don't let you connect in an insecure manner. They're going to force you to use things like managed identity for the most part. Also, as mentioned, we're not transiting over to the public internet. We're staying within Azure machines, staying on the Azure network. But at the same time, there are only a limited number of services that are available as managed private endpoints. And they're all Azure, obviously. You can't have a managed private endpoint to AWS because then you would still be transiting over the public internet. So whenever possible, whenever you are connecting to supported services that offer private endpoints, I highly recommend doing this. There are more steps for setting up a managed private endpoint. You do have to basically allow the networking, allow the connectivity between the two. There are some instructions on how to do this. I even have blog posts that show how to do this. But once you've done it, you only really have to do this once. So per resource, per combination, you create one managed private endpoint, and it just works at that point. Okay. We're working our way down through securing Azure Synapse Analytics. Now we're going to talk about the three pools. First, let's talk dedicated SQL pool. To secure the dedicated SQL pool, one of the first things I would recommend is get familiar with role-based access controls. So if you're familiar with SQL Server, you're already going to understand the role-based access controls in Azure Synapse Analytics dedicated SQL pools. We have logins, we have users, we have built-in database roles, we have custom database roles. So you create a login for an instance, you create a user for a database, you can assign users to roles, and you can create your own roles. Within these roles, you can control permissions. Now you can also control permissions on users. So you control permissions using grant, revoke, and deny. Grant, you are allowed access. Deny, you are forbidden access. Revoke, whatever I said, ignore it. Ignore that last bit. So if I grant you access to a stored procedure, but then I revoke that access, you are no longer granted. If I deny you access to the stored procedure, but then I revoke it, you're no longer denied. So you can control access to different objects for various roles using those permissions, those grant, revoke, and deny operations. One thing that is important is permissions are inherited. So if I am a user who is in a role, I will get all of the grants and all of the denials from that role. Revoke, as I mentioned, resets a grant or deny. Kind of treats it as, that never happened. Deny supersedes grant. What is really important here is it doesn't matter how far up or down the chain that deny happens, it's dead to you. This is even if we explicitly grant on the user. Let me give you an example of what I mean. We have Suzanne. Suzanne is a developer. She is in a developer's Azure Active Directory group. We have granted developers DB data reader on a user database. So developers are allowed to read all tables. In addition, we have denied select on dbo.finances to the developers group. What that means is they can read every table except dbo.finances. Now, Suzanne cannot access dbo.finances because she's in that group that's been explicitly denied. But we want Suzanne to get access to it. So we explicitly grant Suzanne select on dbo.finances. She still cannot access that table because a deny in a dedicated SQL pool overrides a grant regardless of the level. In some systems, a lower level grant will supersede a higher level deny. So in other words, my role denies me, but my explicit permission grants me. Some systems will override the deny and say, okay, you're granted. Dedicated SQL pool says, no, there's still a deny in here. Don't care if you've granted Suzanne, she's still denied. By the way, if you really are in that situation and Suzanne absolutely needs to get access to that table, you may be in a scenario where you'd want to remove Suzanne from the developer's role and add Suzanne to a finance developer's role. So you may have to have more fine-grained groups in that scenario. So now let's talk database roles. User database roles, basically the same as what's in SQL Server. DB data reader, DB data writer, et cetera, et cetera. Some roles that are in the master database only are not in SQL Server on premises. First is DB Manager. DB Manager allows you to create and drop databases in a dedicated SQL pool. DB Exporter, create tables, alter schemas, work with Polybase. DB Exporter is important because normally to work with Polybase, typically you need to grant control. So DB Exporter is essentially the equivalent of that limited version of granting control. There is no sysadmin in a dedicated SQL pool, not in this sense, which is why we need DB Manager, DB Exporter, and Login Manager who can create and delete logins. You can also associate an Azure Active Directory account as essentially your administrator, and that Azure AD account can then create new logins and assign these roles to those logins to bootstrap your way through. When it comes to data at rest, we talked about data in transit. It's all TLS 1.2 encrypted. Data at rest in a dedicated SQL pool, always encrypted using Microsoft keys. If you don't want Microsoft keys to encrypt your data, basically the answer is too bad. That's going to happen automatically. Now, if you're in an organization where you say, I don't trust Microsoft to, not read my data, you may also double encrypt your data. So if you use a customer managed key, you are able to take that encrypted data and encrypt it again using your customer managed key. Your dedicated SQL pool data will now be double encrypted. And double encrypted is still fine. There's no security risk there. There's no real performance penalty there either. It's extremely minor. If you do not double encrypt your workspace, you may alternatively enable transparent data encryption on your dedicated SQL pools. Transparent data encryption works basically the same way that it does on premises. This does have a CPU performance hit, a few percentage points. Also, all of those backups, all of those snapshots, they are written out to encrypted disks. So nowhere is your data unencrypted when it's sitting on disk. Within a database, if there are specific columns that you want to encrypt, you can use column level encryption. This is the old SQL Server 2000 style of column level encryption using encrypt by key and decrypt by key functions. Now, I say that it's old SQL Server 2000 style, but there's a little bit of a twist here. And the twist is that if you go to the SQL Server documentation, you can choose to use an algorithm like RC4 or DES or triple DES. Azure Synapse Analytics forbids that. You may use AES 128, 192, or 256-bit encryption for the symmetric key. Triple DES, RC4, not supported. They are still supported on premises in SQL Server, but you really shouldn't use those. The only reason they're still supported on premises is because there's some organization that's running with like 25-year-old security encryption mechanisms and haven't gotten around to using something that is not horribly broken. RC4 is horribly broken. DES is horribly broken. Triple DES, horribly broken. None of them are considered secure at this point. I'd even be a little concerned about AES 128. Technically not broken, but it's like every encryption mechanism. You're just waiting for that day when someone finally weakens it enough that you can brute force attack it. So I would recommend AES 256-bit encryption for those sensitive columns. If you are familiar with always encrypted, not supported with dedicated SQL pools. So you'll have to use column level encryption if you wish to encrypt data within your queries or within your tables. How do we do this? Well, glad I asked. First thing we need to do is create a master key. This master key could be secured with a password, but for the dedicated SQL pool, does not need to be. Then we create a certificate. So this certificate is going to give us the ability to create a symmetric key. Our symmetric key, we might call it personnel key. And our algorithm, AES 256, encrypted using the personnel cert certificate. So given this certificate, we're going to create a key, a symmetric key. I can create a new column. Let's say we've got a last name and we have a need to encrypt the last name. Then I can open up that symmetric key using the certificate to enable decryption. And I can update the people table, set the encrypted last name to be the result of this function, encrypt by key, and I send in the key GUID of personnel key. So it goes and it finds out which key that is, and it will encrypt the last name column on the table. It'll spit out some binary results. So I'll cast that as var binary 160, and I'm going to update that column on my table. Then if I want to read that column later, I can open up the key, decrypt with that certificate, select convert to in varchar, decrypt by key, last name encrypted. So I don't have to specify the key that I used here. What is interesting is that SQL Server and the dedicated SQL pool both understand intuitively which key actually was used. So they'll know what certificate is necessary, what key is necessary to decrypt the data. Once you're confident that encryption and decryption works just the way you expect it, you can drop that name last column. And now you have an encrypted column so that only people who have the ability to decrypt that data will be able to see it. And one way that you could control that is with a stored procedure that will do the decryption, and maybe you grant the stored procedure only to specific users or to the application users. Turning away from security and toward non-security options, dynamic data masking. This is not an alternative to encryption. Dynamic data masking is a mechanism to prevent shoulder surfing attacks. So shoulder surfing attack is you have a screen up, I walk by your desk, I see somebody's private information that I probably should not have seen. Dynamic data masking can, instead of returning the actual information, return some masked version of that information. That said, if you have the ability to query the table in which this data lives, you can fairly trivially defeat dynamic data masking if you are a malicious user or somebody who is intent upon understanding what is under the covers. So using where clauses, using common table expressions, using clever configurations of queries, you're going to be able to get the right values. This is why this is not really a security feature in the sense of protecting a malicious user. It's just really a shoulder surfing prevention. Row level security is going to allow you to use a group membership or some other identification and say, you are allowed to see this row, you are not allowed to see this row, or this row, or this row, but you can see that one. So we create what is called a filter predicate. That is essentially, do you get to see this row? And it iterates for every row. Assuming that you have some column that you can filter in the table, we can create a function that will return 1 if you're allowed to see that data, and null if you're not allowed to see the data. We create a security policy to tie that function to the column, and this definitely will have a performance impact. This will absolutely slow down queries. So let's talk about what it does, how it works. First, to give you some baseline information, I have some data that is baseball related, and I have teams who are allowed to see data for their team only. They may not see it for any other team. So I've created a team for Atlanta, and they have a login, they have a password. Then I create a user from that login, and let's say that I also have an internal person named Alicia. Alicia is going to be allowed certain rights for a few teams. She is a business analyst who works for the company and might be a consultant who gets to analyze data from certain teams. So we have the Atlanta user who can see Atlanta data. We have Alicia who can see a few teams' data. Then I create a function. This function takes in an input, team ID, and returns a table that selects 1 as success if certain conditions are met. So if team ID is the first 3 characters of the user's name, so ATL, if the team ID is ATL, Atlanta user will be able to see it. Or if the username is Alicia and the team is one of the ones that she is allowed to see. So I can create whatever criteria I need for this function. And I'll create a security policy that says on the dbo.pitching table, use the team ID column that is on that table as our input and turn this on for row level security. Then we're going to grant select on the function team predicate to anybody who needs it. And that way, when Atlanta user queries the pitching table for the year 1995, they'll see their team's data. When Alicia queries that same table with the same conditions, she'll see data for 3 separate teams. The people will be able to see different data. But importantly, we scan the entire data set. So if you have 1 billion rows and row level security filters you down to 150, well, your where clause, depending on how you've written it, you may still be scanning 1 billion rows to get just 150. And as you would expect, that's going to be a performance pain. Next bit, data discovery, classification. So data discovery allows you to classify specific columns and apply sensitivity labels to them. As an example here, I have the people table. The birthday is picked up as date of birth, which this tool said, hey, that looks like something that may be covered under GDPR. City of birth, city of death, those seem like they're confidential information. So the tool can go through your dedicated SQL pool and automatically make recommendations on which columns look like they are sensitive, and here's how we might classify them. In addition to that, you can make your own sensitivity judgments, which means I might say, actually, city of death is not sensitive information. That's public info. So I could change that if I wanted. But, you know, you missed this column here because it had a weird name, but I know that it has sensitive data in there. So we can control the results of this. And then whenever somebody queries that classified data, we're able to review what they've queried. So I can read audit files. Here's an example of an audit file that I created, and I'm able to check to see where data sensitivity information is not blank, and I can see quite a bit of information. Here, what I see is just the fact that it did run. Here was the time that it ran. Here was the session that ran. But we could also scroll over to the right and see who ran it, what was the query that ran, and basically get an idea of, were you in fact writing queries that were, say, necessary for your job? A great example of this is in the world of hospitals. If you are a nurse, you may only access data for patients who are on your floor, on your shift, when you have the appropriate right to access them. You may not go searching around in the hospital system just looking for patient names. That way, for example, if a nurse knows that there's somebody very famous who happens to be at the hospital right now for whatever reason, that nurse cannot go looking for the famous patient. And there are systems in place that if you start randomly searching for people who are not part of your duty assignment, they will fire you. I've known enough cases. I've worked in the medical field, medical industry enough to know that does happen. People do get fired for that. And tools like this will help you understand, are people writing, are they searching appropriately, or are they misusing the power that they have? Let's talk now about the serverless SQL pool. Role-based access controls, very similar to what we have in the dedicated SQL pool. We still have logins, we still have users, we still have roles, we have grant, deny, revoke permissions. So all of that is the same. One of the big differences, though, is that the serverless SQL pool is almost entirely read-only. We do not insert data into the serverless SQL pool. We do not delete data, update data, merge data, truncate data. We don't really do any of that stuff. We cannot create normal tables and modify records in there. We can access data from the data lake using either the open row set command or creating external tables through Polybase. So what this means is our roles are really limited to granting access to open row set, granting access to Polybase, querying external tables that have been created using Polybase, querying views that might use open row set or Polybase. So open row set, to use this, requires Synapse User, the RBAC role in the workspace, and grant administer database bulk operations in the serverless SQL pool. On premises, that's a pretty powerful role. That allows you to do bulk operations in SQL Server. In the serverless SQL pool, well, it's just open row set. You can't bulk insert. You can't do other bulk operations. It's really just open row set queries. So scary sounding, not actually scary in the serverless SQL pool. If you want to work with Polybase, you're going to need Synapse User Workspace role. To create and drop external tables, you're going to need the control permission. Doesn't matter if it's on-prem, dedicated SQL pool, serverless SQL pool, the control permission is powerful. You have just shy of sysadmin rights. You have a lot of power in that space. Creating and dropping external tables in the serverless SQL pool is pretty much the most powerful thing that you can do in that environment. If you want to read from an external table, you're going to need DB Data Reader or DB Owner, or be granted explicit select rights on that external table. So you don't need control. You just need control if you want to create or drop the external tables. Just to query them, it's simple selects. What I would recommend, if you do work with the serverless SQL pool, reading data from the data lake, you can use a managed service identity. So this is where I was talking before that you have these service identity accounts, the managed accounts that we can create or that get created for us as part of the system managed accounts. Well, we can take advantage of this managed service identity and access our data lake using it. If we have the appropriate permissions set up for our Synapse Workspace's managed identity to query some external resource like a data lake, like blob storage, all we have to do is use the identity and create our external data source using the credential that is based off of that identity. No passwords stored anywhere. As a fallback, you might need to work with shared access signature tokens. This is especially true if you're working with blob storage where, for whatever reason, you're not able to grant the managed identity rights to it. Maybe you're pulling in data from some third-party Azure resource and they're willing to create a SAS token for you, or you have a process to create a SAS token, but they're not going to allow that managed identity hookup. SAS tokens allow you to create a limited access to specific resources. So I can create a SAS token that limits you to just this container, just this folder within the container, just these files. And I can say, you're allowed to list everything in this folder, read, write, delete, stuff like that. But I can also control and say, you're allowed to do this for the next 12 minutes. And then you have to go get a new token. We can only allow these IP addresses. So I can whitelist specific IP addresses and say, only this IP address is allowed to access data from the container. That way, if a bad person happens to get that token, unless they're coming in from the same machine or from the same IP address, they're not going to be able to get any information using that token. If you do need to create such a token, here's an example of me creating one using the AZ CLI. So I have a storage key that I store as an environment variable. I say, I want this to last until 30 minutes from now, and I'm going to generate a SAS token whose name is Synapse. I must access it over HTTPS, TLS 1.2. I can delete, list, read, and write. It'll end 30 minutes from now, and my account name is a storage account name. So let's now talk about the Spark pools. With Spark pools, we have two different types of isolation. One type I talked about before, network isolation. If you're using a managed virtual network, each Spark pool is kind of isolated in its own subnet, so they can't communicate with each other. Physical isolation, if you use triple X large, so triple XL node sizes in specific regions. East US is one of them. There are just a couple of regions that allow this. But if you use XXXL as your node size, which by the way is extremely expensive, you can get physical isolation of the compute, meaning this machine, this physical machine is all yours. Nobody else is going to have anything running on it. So very expensive, but if you absolutely need it for your Spark work and you're willing to pay enormous amounts of money, you can get physical isolation in Azure for Spark clusters. If you want to create a Spark pool, you're going to need to be a Synapse admin or a Synapse Spark administrator. You're also going to need to have that contributor or owner IAM role. If you want to run a Spark notebook, Synapse admin, Synapse contributor, Synapse compute operator. Note that Spark admins cannot run notebooks. If we want to use the data lake, that goes back to you're going to need storage blob data contributor if you want to write anything out using your notebook. So for a lot of Spark operations, you're going to need to write results out to the data lake. I mean, that's kind of the output that gets generated, which means you're going to have to get storage blob data contributor. Lake databases are a way of allowing the Serverless Sql Pool, the Spark Pool people to communicate over the same data lake. The idea is we realize we're using the same data lake, and some people want to write SQL, some people want to write Python, Scala, or Spark SQL. Lake databases are our way of having combined consistent metadata between those two spaces. We secure lake databases like Serverless Sql Pool, like Spark pools at the storage level. If you want to grant rights, we're going to grant your ability to read a file and execute on folders. The database creator is the owner of the database and has all rights. So if I created a lake database, I have full rights on it. In addition, if you're a Synapse admin or a Synapse Sql administrator, you're going to have full rights as well. When it comes to working with Spark clusters, a very common idea is I need to bring in libraries. I need to work with Python packages, work with Java jar files, Java archives. Spark pools come with a variety of packages and libraries preloaded, but you may have additional ones that you want to bring in. Those could be third-party libraries that you want to incorporate. Those could be custom libraries that you've built that you want to bring in. So for Java and Scala, Synapse does not support Maven. Maven is a package manager in the Java space. It doesn't support any Java package manager. If we want to install Java packages, if we want to install jar files, we are going to run in the Synapse workspace, go to the Manage menu and install packages at the workspace level there. This is not as convenient as with Azure Databricks. I think they've still got a ways to go before your interaction with Spark, Scala, and Java packages is anywhere near what it is in Databricks, but you can install that way. For Python, things are a little easier. You can install Python packages using pip, and you can also specify a conda requirements file, so requirements.txt file. We can additionally import wheel files from the Manage menu in the Synapse workspace, sort of like we did for Java, for jar files. To import libraries, once again, we need that storage blob data or storage data blob contributor. But we actually don't need additional permissions if you just want to bring in a library. That said, custom libraries are a great way to introduce security vulnerabilities. Packages change a lot. There are security vulnerabilities in older versions of packages. And if you access your packages from a public resource, there is always the chance that you'll have something that is exploitable that you've installed on your Spark cluster. You can control this by using a custom conda channel to control and version those packages. So your security people might vet packages before they get added to this custom conda channel, and then you can pull in from there. You could also use versionless package specifications to make sure that you get the latest version of a package instead of limiting yourself down to a specific version. This comes with upsides and downsides. The upside is you're not going to get locked in on a package that's old and vulnerable. But the downside is that in the Python world, they don't tend to be as nearly as backwards compatible with APIs as in the .NET world. So if you're working with Python, if you're working with R, stuff tends to break pretty frequently when you go from version to version, and package maintainers tend not to care nearly as much. A little bitter about that because this is what I do in my day job. If you have data exfiltration protection, you will not be able to access pip. You will not be able to access conda. You will not be able to access any external websites. So what you can do in that case is you can put those packages in your data lake and load them in from there. That's the way to do it. So not nearly as convenient, but when you're not allowed to access the public internet from your Spark cluster, you got to do what you got to do. Sql Pools will allow us to query Key Vault for access to resources. I highly recommend only store your resources secrets in Key Vault. Don't store them in notebooks. Don't have them in code. Use the token library, which is a package that is built into Synapse to access secrets. It has access to hit your Key Vault. You can grab a secret from there. You can work with it from the token library. The Synapse Managed Service identity needs to have secret Git privileges on the Key Vault in order to be able to retrieve that data. So as we wrap things up, we've done a little diving into pools. I want to talk about a couple of additional tools that can help you secure that Synapse Analytics workspace. One is Microsoft Defender for SQL. This includes two key components, and that assumes that Microsoft Marketing has not changed the name of the product in the past week. Knowing them, they might have. Hello, Azure Purview. First thing, SQL Advanced Threat Protection. The idea here is you're going to get an alert on suspicious events. A great example of this, a colleague of mine, he went to Bonaire for a dive, and Bonaire is an island in the Caribbean. And when he logged in to do some work, our security person got an alert that said, hey, this person logged in from Bonaire, and reached out like, are you actually in Bonaire right now? And so my colleague's like, yes, I am in Bonaire. And our security person was able to say, okay, yeah, this is still legit. You can do this geographically based. You could also do a straight block where you say, you know what, this person is never going to be in Kyrgyzstan. And therefore, if anything comes in from that country, just not going to permit it at all. We're just going to outright block it. If he happens to go to Kyrgyzstan at some point and tries to connect, too bad, you can connect when you come back. The Sql Vulnerability Assessment is the other tool that can be helpful here. This is an automated scanning service that helps you follow good practices. It'll indicate that, for example, hey, did you know that you have 14 people who have administrative access? Or you have everybody in this database is an administrator. You don't have any non-administrative accounts. Those are the types of things that the vulnerability assessment can help you with. And it helps you create a baseline of where are you today and where do you need to be. Azure Policy allows you to enforce organizational standards and ensure compliance. You define what they call business rules. These rules are defined in JSON, and they are applied to any resources that are created in Azure. So policy can help make sure that you have configuration options turned on, can help you make sure that logging is set up appropriately, that you have done certain things, even deny resource changes if particular circumstances are not met. So there are quite a few policy definitions that are built into Azure Synapse Analytics. And somebody asked about this before we got started. This is the link that I want to hand off. And this takes you to Azure Docs, where they tell you, hey, auditing should be enabled. So you can check out this particular business rule. And here is the JSON for that business rule. So we could walk through the description of what that policy looks like, and we can apply that in our own environment and enable that, if you don't have auditing on the Synapse workspace, we're not going to let you create the workspace. So that's an example of one thing that we could do using Azure policies. And I want to bump that back down. So there's quite a few opportunities for policies that are there. You can also create your own custom policies. These are just ones that they've created up front to make life easier for you. So let's wrap up. Over the course of this talk that's gone on for basically an hour and a half, we've looked at different ways to secure Azure Synapse Analytics. And I know that I've stayed at a very high level. This is my one commercial pitch. I did create an 8-hour training for the EC Council for their Code Red platform on securing a data warehouse using Azure Synapse Analytics. This is about 8 hours of training in which we go through all of the things that I covered, just in a lot more detail, and where I show demos of everything in action and share the scripts for it. So check that out if you want to. I will drop one link in here for that training if you are so inclined. But if you want to grab these slides, if you want to grab links to other resources that are entirely free, go to csmore.info/on/lockdown. And if you have any questions at all after today, you're welcome to reach out to me. There is my email handle. Here is my Twitter handle. And with that, are there any questions?
Thank you very much, Kevin. At this stage, no, there's no questions, but if anybody has any questions, feel free to put your hand up and we can take you off of mute to ask any questions from Kevin on anything from today's session.
I have one question. It's a generic question, and this is because we've been working on the Synapse world, and we're looking at what Microsoft roadmap is with regards to Lakehouse and all the sort of stuff. We are in a dilemma right now where we're actually looking at Synapse itself persists the data, and in wider tools like Serverless Synapse and all the stuff coming through, where it actually promotes the idea of persisting the data in the data lake, and Synapse just creating the view, right? To basically read-only view, as you talked about. So do we, and does the direction from Microsoft in terms of Lakehouse and all this research tries to now recommend that, Synapse is not meant to be persisting data, but it's based to be, it should be offloaded into the data lake, and then you should use Serverless Synapse or Spark or all this other stuff? Do you have a view on that?
Yeah, so the short answer is both yes and no. The dedicated Sql pools, there's a lot of value in them, and there's a specific use case for them, and that is around Kimball style warehousing. So if you are using a Kimball style warehouse, lake houses are going to be painfully slow in comparison. So there's a huge benefit in keeping the data within your dedicated Sql pool. For cases in which you're spelunking, for cases in which you're doing maybe smaller business analysis, where you're doing the type or machine learning, in those cases, they do recommend, okay, work with this data lake and let's communicate with the data lake through a Spark pool or through T-SQL via the Serverless Sql Pool. So there is a little bit of a two-headed, maybe three-headed Hydra scenario, where the third head is data explorer pools, which I don't even talk about in here, store data themselves separately than the Spark pools, Serverless Sql Pool, and the dedicated Sql pools. So this is a bunch of products that are tied together, and I don't think there's just one set of advice that says keep your data in this one location only. I think 4 years from now, if you ask that question, the answer is probably going to be that yes, keep everything in the data lake and we just read from the data lake. But performance isn't there yet to make that a reality in most scenarios.
Okay, so
Mike, I know you had your hand up. Did you still have a question? Feel free to come off and ask your question.
Yeah, thank you. So we allow certain people to access the data lake via the serverless endpoint. And currently we're whitelisting those individual IPs. Hence my question before. Is a robust RBAC policy enough to then open that firewall to the public?
I would say yes, and I would also say I am the debate I'm having in my head is I know the people who would say no, and I don't strongly disagree with the people who say no. So the ideal route is that instead of opening up to the public internet, we do use that VPN where you're only allowed to connect to this resource over VPN. And
so we
in
use
that
Citrix,
case,
and people hate it.
yeah,
Citrix is not quite a VPN, but it is what my company has implemented.
Right.
And the resistance to it has been so much from these power users, let's call them.
Mm-hmm.
They want to use their own laptop. They want to be off the company network. They want that serverless endpoint in a Jupyter notebook where they can do as they wish.
Yeah.
But then how do you control data exfiltration?
Right. So that's one of the key concerns.
Yeah.
Where, yeah, at that point, if it is publicly accessible, I would say the combination of, role-based access controls, of using Azure Active Directory authentication, especially if you have multi-factor authentication, and of that IP whitelisting is going to be good enough to stop internet riffraff from getting in. So it does meet necessary security requirements. The question is, how much further beyond necessary security requirements do you need to go for an organization? And that's where I think a lot of the debate would be. I know that people whose job is security are going to try to come down on that really hard. So I am sympathetic about having to use Citrix. I have had to use that in the past as well. And I guess basically it's like, okay, well, you can use, here are your options. You can use Azure Bastion. You can use this VPN.
I don't think Bastion was access to anything other than an Azure VM at the moment. Have they made access to Synapse available?
So the idea would be that the Bastion would allow you to access a VM, and then that VM would have rights to be able to hit the serverless Sql Pool. So they could have Jupyter notebooks installed. They could have the tools installed there.
Gotcha.
This is going to cause a whole new set of complaints, but
something you touched on earlier was it's possible to peer your own VNet to the managed VNet. I haven't found any links to that at all yet. I've actually spent a bit of time looking. Is that something that you mentioned? It's extremely difficult. It's possible though.
Yeah. So it was specifically around peering to allow only access, basically that you had to that you could only access the Synapse workspace that what is it, studio.azuresynapse.net or whatever that URL is, that you can only access that through a Bastion or through a server that's basically a machine on VPN. And I'm going to have to dig up that URL because I remember going through it. Not even try. It's not even in the course that I talk about because that was very complex. So I'm going to try to dig that up, and if I do find it, I can pass it along to Warwick, but and also add it to the links. But yeah, that was something I remember seeing once, and I forget exactly where it was and who wrote it. But there is a way to lock down that access to the studio website.
Thank you.
Okay. Does anybody else have any final questions for Kevin before we wrap up this month's session? No. Okay. Well, with that, I'd like to thank Kevin for giving up his time in coming along and joining us today and presenting to us on locking down Azure Synapse Analytics. I'd like to thank Martin for co-hosting with me, and I'd like to thank you all for attending this month's session. If you haven't already signed up, next month's session, bear with me a second, my computer is just running slow, but next month's session we have, come on, while that's coming up, there we go, we've got simplify data management with partitioning. So feel free to register for that one, come along, join us next month. This session, as mentioned at the start, was recorded and will be made available on the YouTube channel once we've finished processing it. So with that, thank you all. Have a wonderful day, have a wonderful month, and we look forward to seeing you all online in a month's time.
Hey, thank you. And by the way, Mike, I just found that link. It was private link hubs for Synapse Studio.
Legend, thank you.
Excellent. Thank you, Kevin. Thanks, everybody.
All right. Hey, take care, everyone.